Good morning, everyone. So let's start today's session. Today we are going to discuss few more constructs related to SQL select statement. So we are going to cover queries on multiple relations, rename operation, string operations, and also we are going to focus upon how to order the tuples in the relation. So let's begin with queries on multiple relations. So far, whatever queries those we have discussed, in those queries we were using a single relation in from clause. But it is possible to extract the information from more than one relations. So the from clause lists the relations those we would like to involve in the query. And if we are having more than one relations in from clause, typically it produces the Cartesian product that we have seen in relational algebra. So if we want to find out the Cartesian product, say for example of two tables, instructor and teachers, then we can write the query in SQL like select star. This is the asterisk, that means we want to extract all the attributes. So select star from instructor comma teachers. So this statement actually provides us the Cartesian product of two relations, instructor and teachers, right? So let's see two instances of these two tables. So this is the instructor table and this is the teachers table that we have. And if we try to form the Cartesian product of these two relations, then obviously what we get in Cartesian product, we have seen the Cartesian product in relational algebra, right? So if I am having instructor cross teachers, what this will produce? This will give me the combination of each tuple from instructor relation with every tuple from teachers, right? So we have seen this. So this is what we are getting as the Cartesian product. So the equivalent SQL statement for Cartesian product looks like select star from instructor comma teachers. So this statement is equivalent to the relational algebra statement, that is Cartesian product. So if we are having these two instances with us, instructor and teachers, we are having, if n number of tuples are there in instructor table and n number of tuples are there in teachers table, then in Cartesian product I will be getting m by n number of tuples that we have seen. So this is the Cartesian product of these two relations. So we are having lots of tuples in our Cartesian product. But as I stated earlier also, Cartesian product by its own will not be useful, because as we are having all the combinations of tuples from both the relations, we may get some tuples those are actually not meaningful, or we may have some tuples those are irrelevant, right? And that is why if we want to write the queries on multiple tables, we need to provide the predicate in where clause to match the related tuples, right, from both the relations. So the predicate that we are going to provide in where clause is used to restrict the combinations created by the Cartesian product to those that are meaningful for the desired answer. So let us try one query. Find instructors who have taught some course. Find instructors who have taught some course. So please refer to our university database and tell me which tables we would like to have, or which tables we should use to write this query. Find instructors who have taught some course. We want to extract the names of the instructors who have taught some course. So which tables to be used? Obviously, instructor name is available in instructor table, so we need to make use of that. And which instructor is teaching which course, that information is available in our teachers relation. So these two relations we need to make use of. So we are writing the query now like this. Select name, comma, course ID. So course ID is available in teachers relation and name is available in instructor relation. So select name, comma, course ID from. We want to use now these two tables, instructor, comma, teachers. As I stated earlier, if we do not use this where clause, then what will happen? We'll be having the Cartesian product of these two. And in that Cartesian product, we may have some irrelevant data, right? And that is why we need to match the common attribute from these two relations. The common attribute in these two relations is the ID of the instructor. So we are matching here in where clause. We are giving the predicate instructor.id is equal to teachers.id. So this is the query that will provide us the solution. Find instructors who have taught some course. So we are listing name of the instructor along with the course ID taught by that instructor. Right? And to have the meaningful result from more than one relations, we should use this where clause wherein we need to match the common attributes. Right? The equivalent relational algebra query, if we would like to write, how we are writing that query, relational algebra query, we need to use projection operation. The attributes, those we want to display are name and course ID, right? In parenthesis, we need to impose a predicate, so selection operation. Instructor.id is equal to teachers.id, that is the predicate, and on which relation we would like to use this predicate, the Cartesian product of instructor and teachers. So this is how we are going to write the equivalent query in relational algebra. So both will produce the same result. Are you getting me? Yes?
Yes, ma'am.
May I proceed?
Yes, ma'am.
Yes, ma'am.
Fine. So let's try to have a demonstration. So let's log into our university schema. Okay, so I'll be demonstrating both the Cartesian product as well as the relevant data that we are getting after matching the common attribute from two relations. So let's try first. Select star from instructor, comma, teachers. right? So see here, we are having lots of tuples. Let us do one thing. Let us visualize instructor table so that we can have the better idea. So select star from instructor. So we are having this data that is stored in instructor table. So we are having 12 instructors in our instructor table, right? 12 instructors. And now let us try to display the data teachers table. So we are having 15 records. Those are stored in teachers table. So in instructor we had 12. In teachers we are having 15 records. So how many records we should have in Cartesian product? Yes?
180.
180. So 12 multiplied by 15, right? So let us see now. What see here the number of records. Are you able to see how many rows we are having in this Cartesian product? Yes. Are you able to see the screen?
Yes, ma'am.
Yes, ma'am.
So here we are having 180 rows, right? Those are present in our Cartesian product, instructor and teachers. So we are executing here the statement select star from instructor comma teachers, right? But if we visualize this Cartesian product result, see here my ID is 10101 and here also the ID is 10101. So this is the matching tuple, no doubt. This is also the matching tuple. This is also the matching tuple. But if we look at this fourth tuple, the ID of the instructor from instructor table is 10101 and we are matching this tuple with the instructor ID, or we are combining, not matching, but we are combining this tuple with the instructor ID in teachers table with ID 12121. So this instructor with ID 10101 who belongs to computer science department has nothing to do with this course, which is finance, from finance department, right? And this is the irrelevant tuple in fact. Why? Because we have not matched the IDs from both the tables, and that is why lots of tuples, those we are getting here, are actually irrelevant. So make our result, to make our result relevant, what we need to do is we need to make use of matching condition in where clause. So we are going to write the query like select star from instructor comma teachers where now ID belongs to, this ID belongs to instructor table also and the teachers table also. So distinguish these two IDs from these two tables. We need to make use of the table name as well. So where instructor.id is equal to teachers.id, right? So we are having this matching condition now. So let's execute this statement now and see here what we are getting. We are having only those tuples for which both the IDs are matching from both the tuples, right? And we are having only 15 relevant tuples in these two tables, right? Now we do not want to display all the attributes, but we are supposed to display only the name of the instructor along with course ID. We are listing out these two attributes here in select clause, right? So the statement becomes now select name comma course ID from instructor comma teachers, where instructor ID is equal to teachers.id, right? And if we execute this statement, see here what we are getting. We are getting 15 records, whereas we are listing name of the instructor and the course that is taught by that instructor. So it may happen that one instructor is teaching more than one courses. So all those courses are being listed. Right? Are you getting me? Yes?
Yes, ma'am.
Yes, ma'am.
Fine. Fine. So now let's go to the next query that I am going to demonstrate you later. So find instructor names and course identifiers for instructors in the computer science department. So what we want? Find instructor names and course identifiers for instructors in the computer science department. So here we need to impose upon one condition. We do not want to list out all the instructors along with courses from all the departments, but we want to have the record of instructor names and the courses taught by those instructors who belong to computer science department, right? So the query that we are going to write is like this. So select name comma course ID from instructor comma teachers, where instructor ID equal to teachers ID. This is mandatory condition, right, to have the relevant results. And the next condition that we would like to impose is instructor dot department name is equal to computer science. Right? Do you agree with me? Yes?
Yes, ma'am.
Fine. So let us try to write the relational algebra operation as well for this query. Only difference is we are adding one more predicate. Right? So projection operation name comma course ID in parenthesis. We should have the select statement with two conditions now. Instructor.id is equal to teachers.id and instructor.department name is equal to comp science. So these are the predicates. Those we would like to impose upon the Cartesian product of instructor cross teachers. Is that correct? Yes? Whether these two are equivalent? Yes or no? Equivalent to one another?
Yes, ma'am. Yes, ma'am.
One is written in SQL, other is in relational algebra. Right? So simply, if now we would like to implement this in SQL, what we need to do is we need to add one more condition here in where clause. So in where we need to add condition and instructor.department name is equal to comp science. Right? So in all we are having 15 records. Now, if we try to filter out these records for comp science, see here, we are having 3 instructors from computer science department and their respective courses. So, we are getting 8 rows now in this result. Got it? Is there any doubt so far?
Yes, ma'am.
Fine. So, let's proceed now. With the rename operation. So, the SQL is actually allowing us to rename the relations as well as the attributes. And the clause that is being used for renaming operation is as clause. So, we provide old name as new name. So, new name is the name that we would like to make use of in rename operation. Okay. So, try to write one query for all instructors in the university who have taught some course. Find their names and the course ID of all courses they taught. Rename name as instructor name. So what we want is, once again we are having the similar query, but only thing is, instead of displaying the column name as only the name, we want to rename that column only for visualization as the instructor name. Right? So for all instructors in the university who have taught some course, find their names and the course ID of all courses they taught and rename name as instructor name. So the query that we are going to write is select name. So name needs to be renamed. So name as instructor name, comma course ID from instructor, comma teachers, where instructor ID is equal to teachers.id. Got it? So this name column is being renamed as instructor name, and this is only meant for displaying. We are not actually changing the column name in the table. This is only the visual effect, only for display. Right? So let us try to execute this query as well. See here, if I try to execute this query, what I am having is name, that is name of this column, and course ID. Okay, as it is. But now I want to rename this column name so that I can come to know that this name is the instructor's name. So name as instructor name. Then the next attribute is as it is course ID. Rest of the things are similar. Right? So if I execute this query, instead of this name, we'll get here instructor name. Right? And as I mentioned, this is only for visualization. The original column name will be as it is. Right? Now, in Oracle, we may omit this as keyword as well. Right? But in other SQL, in other RDBMS, we need to make use of that as clause, but in Oracle that is optional once again. So select name, space and new name. This will also work in the same way. Right? So either we may provide here as keyword, or we may omit that keyword and simply we may give some other name. Okay? Are you getting me? Yes?
Yes, ma'am.
Fine. Now, it is also also possible to provide the rename operation like this. Suppose I want to write here name of instructor, specifically course ID, as course identifier. Suppose I want to have these names typically for visualization, then this will also work. See, I have changed name of the column as name of instructor, and for course ID I have changed the title for this column as course identifier, right, in double quotations. So it is possible for me to give some other names to the columns, right? Am I clear? Yes?
Yes, ma'am.
Fine. So let's proceed now with the next concept of tuple variables. So tuple variables are defined in the from clause. In the from clause. And here also we are making use of this clause as. Right? So let us see one example. For all instructors in the university who have taught some course, find their names and the course ID of all courses they taught. And here in the earlier case, we have renamed the name of the attribute. And here we are going to rename name of the relation. And this renaming operation is known as providing the tuple variable, right, by making use of this as clause. As I stated, in Oracle, if we are making use of, even we need not use this as clause. Simply by giving a space, it is possible to rename the relation as well. Okay, so renaming the relation in from clause means we are defining the tuple variables. Okay, so see here the example how we are going to write this query. So select t dot name comma s dot course ID from instructor as t, teaches as s, where t dot id is equal to s dot id. So what we have done here is we have renamed this instructor table as T and this teachers table as S. Why we need to rename the relations? There are several reasons. If the names of the relations are too big, and many times if we need to make use of these relations, then we may abbreviate, we may rename these names of the tables or relations with some short names like this, right? That is one reason. The second reason why we need to make use of these tuple variables is, like, if we want to make use of the same relation more than once in from clause. If we want to use the same relation more than once in from clause, then also we should rename one of the instances of that relation, right? So these are the reasons why we need to change the names of the relations, just to simplify our task. And if the same relation is being used more than once, then also we need to make, or we need to rename these relations. Okay, so this is how we may write the query using the tuple variable. So here this capital T or this capital S are known as the tuple variables. Those are being used to rename actually the relations, right? In Oracle, as I stated, we need not use this as, right? So in Oracle, our syntax will look like this. Select t.name, comma, s.course ID from instructor T teaches s where t.id equal to s.id. If we are making use of these tuple variables, we may refer to the attributes from these relations by making use of this tuple variable. See here, we are not writing here instructor.name, but instead we are writing here t.name, comma, s.course ID from instructor T teaches s where tid equal to sid. Got it? Is there any doubt?
No, ma'am.
Fine. So let's try to implement this practically. So what we are going to do is select t.name, comma, course ID from instructor. We are renaming this relation as T, and teaches we are renaming this as S, where instead of writing now instructor.id, we may write t.id equal to s.id. Right? And we'll be getting the same result. Got it?
Yes, ma'am.
Fine. So this is how we can make use of these tuple variables. Now let us see one more example actually to make the idea very clear. Find the names of all instructors whose salary is greater than at least one instructor in the biology department. Find the names of all instructors whose salary is greater than at least one instructor in the biology department. So just think on, if we want to execute this query, if we want to write this query, we have written the similar query whenever we discussed relational algebra, right? So what we need to do is we need to compare the salaries. Find the names of all instructors whose salary is greater than at least one instructor in the biology department. So we need to compare the salaries, and the salaries are stored in instructor table. And if we want to compare the salaries, then two salary attributes, what we want is we want the salary attributes or two columns of salary attributes in single tuple. So here I may have one salary and here I may have another salary that I want to compare, right? So I need to have these two salary values in this single tuple. Then and then only it is possible for me to compare, to write such kind of the comparison operation, right? So I need to make use of this instructor table twice while writing this query. I need to use this instructor table twice while writing this query. So how I'm going to write this query? Select distinct t.name from instructor as T, instructor as S. So two times I want to use instructor table. So once I am referring to this table as T, at another instance I am referring to this table as S, right? So So select T dot name from instructor as T, instructor as S, where T dot salary is greater than S dot salary and S department name equal to biology. So what will happen here is I am comparing now two salary values, right? So salary value from first instance and the salary value from the other instance. Okay, so the first salary value I'm checking sorry, I'm checking the first salary value whether it is greater than the second salary value in my table. Okay, and also simultaneously I am making sure that this S dot department name equal to biology. Why? Because what I want is I want to find out the names of the instructors whose salary is greater than at least one instructor in the biology department. At least one instructor in the biology department. So for whichever instructor from biology department, if it happens that the salary of the instructor is greater than the instructor in the biology department, then that tuple will be extracted from this data, right? So I'll show you practically what is actually happening. So in Oracle, if we want to give this statement, we are writing the statement select distinct T dot name from instructor T, instructor S. We are omitting this as keyword because that is not required in Oracle. Okay, where T dot salary is greater than S dot salary and S dot department name equal to biology. So let's try to write this query practically so that we can understand what actually is happening. Okay, so distinct T dot name from instructor T. Two times we are using this instructor table. So instructor T, once again instructor S, T dot is greater than S dot salary and S dot department name equal to biology. Before executing this statement, let me execute this instructor. Let us see instructor table first. See here, we are having instructor, and what we want to extract name of the instructor such that the salary of the instructor is more than at least salary of at least one instructor from biology department, right? So let us see here how many instructors are there in biology department. Only one instructor is there, and the salary of this instructor in biology department is 72,000, right? So what we want is we want to list out the name of the instructor such that the salary of that instructor is greater than this 72,000. Okay, so let us try to execute now. Department name DEPT. So what we are getting is those are the instructors whose salary is actually greater than the salary of the instructor in biology department. Okay, so these many instructors are having the salary greater than 72,000. That is the salary of the instructor who belong to biology department. Right? So this is how we have executed this statement. Now let me give you few more insights. So let us try to find out first the Cartesian product of these two relations. Instructor, Cartesian product, instructor. So let's have a Cartesian product of instructor and instructor. So what we will get? We are having 12 tuples in instructor table. So 12 multiplied by 12. So 144 tuples will be having. 144 tuples will be having. Right? Now, what we are imposing here, the condition is like this first salary column is from T, first instance of instructor. So first salary column belongs to this T and second salary column belongs to S. Right? So the condition says that T dot salary is greater than S dot salary. T dot salary is greater than S dot salary. And simultaneously the person from this S should belong to biology department, right? So that is also the condition. S dot department name. So this department name must be biology. Okay. So if we look at the first tuple in this Cartesian product, then whether T dot salary is greater than S dot salary, no. So this will not be included. Whether for second T dot salary is greater than this S dot salary, no. For third tuple, whether T dot salary is greater than S dot salary, yes. But whether the department is also biology, no. So the second condition is not satisfied. So this third tuple will also not be included. What next? Fourth tuple. 65,000 greater than 95, no. 65 greater than 60, yes. But the department name is not biology. So this will also not be included. Then 65 greater than 87, no. 65 greater than 75, no. 65 greater than 62, yes. But department is not biology. Here 65 80, no. 65 72, no. 65 92, no. 65 80, no. So none of these tuples will be included in the result. Right? Now, what next? 90 greater than 65, yes, but department is not biology. So let us try to find out now the tuple. See this tuple. So we are having 90,000 greater than 72,000 and department is also biology. So obviously this instructor Wu is having the salary greater than at least one instructor from biology department. So the instructor from biology department is Crick, whose salary is 72,000, and this Wu is having the salary greater than this 72,000, that is 90,000, and that is why this Wu would be included in our output. And similarly, other instructors will also be identified. So this is how this statement will work and will produce the desired result. Right? Have you understood? Yes?
Yes.
Yes, ma'am.
So the essence is, if we want to make use of the same table more than once to write a particular query, then we should rename the relations. and this is called as the tuple variable. Okay, so let's proceed now with some string operations. So we are having some string matching operators to compare between these character strings. So typically the patterns are described using two special characters. And what are these two special characters? The first character is percent and second is this underscore. So this percent character is used to match any substring, whereas this underscore is being used to match any single character, right? And if we want to use the SQL statement to express such kinds of patterns and the comparison between these patterns, we are having a special keyword like. Okay, so let us see one example so that the idea gets clear. Suppose we want to find out the names of all departments whose building name includes the substring Watson. What we want? We want to find out the names of all departments whose building name includes the substring Watson. So we are going to write the statement like select department name from department where building like. So we are making use of the keyword like. So building like this string. So what this string is? We are having percent Watson percent. What does this mean? This percent may be any substring and this percent may be any substring. Okay, and in between these two we are having this word Watson. So if my building name includes anywhere this Watson substring, then that I am going to retry in my output, right? So building like percent Watson percent. So percent character matches any substring. Okay, so enclosed between 2% we are having this Watson. So this person may be anything, this person may be anything, but if I find this Watson as the substring in this building, then I'll be retrieving that department name. Okay, now see few more examples. If I'm writing this string like intro percent, what does this mean? If I'm having such kind of a string enclosed in the quotations, then this will indicate that I want to match a string such that this string begins with intro and rest of the characters are anything, right? So my string should begin with this word intro and then anything. So if I'm having, say for example, once again, if I'm having a string like percent comp percent, so this matches any string containing comp as the substring. For example, introduction to computer science will be included in this particular notation, or if I am having the course name say computational biology, so I am having comp word here in this course name, so this course name will also be included in this, right? But if I am having intro percent, then see here, if I am having intro and then percent, then it is possible for me to extract this introduction to computer science, because first 5 characters are intro and later on I may have anything, or introduction I may have a course name like Introduction to Machine Learning, suppose. And if I'm enclosing this string to match intro percent, then this course name will also be included in my result. This introduction to computer science will also be included in my result. So depending on whatever is our need, we may use the combination of these special characters along with the substrings, those we want to look for. Suppose I am enclosing in quotations 3 underscores. 3 underscores. What does this mean? This means that we want to match any string of exactly 3 characters. Exactly 3 characters. Because we are having enclosed 3 underscores here. Right? If I am having 3 underscores and 1% sign, then this will match any string of at least 3 characters. So I must have 3 characters, and later on I may have anything, but the string should have minimum 3 characters. So this is what we mean by this string, 3 underscores and then percent. If we are having only 3 underscores, this means that we want to match any string of exactly 3 characters. So we want to have a string which is having exactly 3 characters, not more than 3, not less than 3. This is what this indicates. Right? So as I stated, depending on our needs, we may use these string operations. So let us briefly look at one demonstration for string operation. So suppose let us try to visualize all the departments in department table. So select start from department. Right? So this statement will provide me all those attributes: department name, building, and budget. Okay. Now what we want is, we want to list out only those department names which are located in the building where we may find this string Watson. So I am writing this statement like select department name from department where building like percent and quotation complete. So what I'm looking for, I want to extract the departments where this building is having this substring Watson. Okay. So if I execute this statement, what I'm expecting 2 department names now. Biology, because in building it is having this substring Watson, and physics department wherein we are having Watson as the substring in this building attribute. So I am expecting these 2 records, biology and physics. And this is what we are getting as the result. Okay. Similar to like, we are having not like as well. Okay. So if I use not like, then what I'll get? I'll get rest of the departments except these 2 where I'm finding this Watson string. Right? Not like. Similar to this keyword like, we are also having not like. So if I'm using this not like Watson, then all those departments wherein building is not having this substring Watson will be provided to me. Is that correct? Are you getting me?
Yes,
Yes,
ma'am.
ma'am.
Fine. Now let us try one more. Select department name. Suppose I want to the department names where building name character P and rest of the string will be anything. What I want to extract department names where the building name begins with P. Okay, so what I'm expecting as a result now, these three departments, finance, history and music, because the building name starts with this alphabet P. Okay, so if I execute this statement, I'm getting these three departments, right? Are you getting me? Yes? Got it? Any doubts so far? Any doubts so far?
No, ma'am.
Yes, fine. So let me proceed with the last concept that I want to cover today. So this is also the string operation. So see here one special case. If in my string itself this special character is present in my string, right? In my string this special character is present. Okay, then if this is the case and if I want to say that I also want to include this percent as the part of my string that I am looking for, then I may use the clause like main. This is the escape character. This is known as the escape character backslash and this percent. So what does this indicate? It indicates that don't treat that percent as the special character, but treat this percent as the part of my string itself. So I am looking for the name main percent. Main percent. So this is part of my string. So if this is the case, then I should enclose this escape character. So like main escape character percent. So this indicates that this percent is the part of my string and this has not been treated as the special character. And the escape sequence that we are using is this backslash. Right? So this is one variation if we are having special characters included in the string. As I stated, similar to like, it is possible to use not like as well. Okay, to search for the mismatches instead of matches. Okay, now SQL also supports a variety of string operations such as concatenation. So if I want to concatenate two strings, then I am using this symbol, right, enclosed in the quotation. Concatenation of two strings can be done by making use of this particular symbol. Okay. Now, if I want to convert from uppercase to lowercase and vice versa, then in Oracle, we are having the functions like upper and lower, right? If we want to find out the length of the string or if we want to extract the substring, then we are having the functions available in Oracle like length, substring and so on. So I would recommend you to look for all such string operations and the functions available in the RDBMS that you are making use of. If you are using Oracle, just as stated, to convert into uppercase, we are having this function upper, to convert it into lowercase, we are having this function lower. Likewise, okay. So you please study all such functionalities. Just I would like to demonstrate this with a simple example. Suppose I am listing out names of the department. So suppose I am listing out all department names from department table, right? And suppose I want to display this. I want to display this in uppercase. Then what I can do is I can use select upper department name from department, so that I can visualize this in uppercase, right? Usually when we are making use of such kinds of functions, suppose I want to find out only the department name, or rather I want to suppose, let us execute this. So we are having 3 attributes in department table: department name, building and budget. Okay, so what I want is I want to extract only the tuple for which the department name is biology, and I do not know in which case I have inputted this department name. Here only the first letter is capital and rest are small, but I do not know that. So what I can do is I can write this statement like select star from department where, so whatever may be the case in which I have stored actually the data, I am converting it into upper. So upper department name equal to, and then I will match the uppercase string biology, right? And if I execute this, I'll be getting only that particular tuple. Instead, if I would have written like department name equal to biology like this, then I will not get any data, no data found. Why? Because department name in actually the table is stored like only first letter, which is capital, and I do not know how it has been inputted, the data. So what I can do is I can write this statement like this, so that I'm converting whatever may be the department name in whichever is the case that has been used to input the data. I'm converting it into upper and I'm matching it with the uppercase string. So I'll be getting the result. So I hope you must have understood whatever I have explained so far. Okay? Is there any doubt? Yes? Is there any doubt?
No, ma'am.
Fine. So, I'll be having a last construct that I want to explain you, and that is ordering the display of tuples. So what we mean by that, and this is really very useful construct of SQL statement. If we want to list out the data in some order, then we should be able to sort our data for visualization. Okay, so let us see one example. List in alphabetic order all instructors in the physics department. List in alphabetic order all instructors in the physics department. So we are going to write the statement like select name from instructor, where department name equal to physics, order by name. So we are making use of a new clause here, and that is order by. So order by clause helps us to order the data as per the attribute provided. So we want to list out the instructors in the physics department in alphabetical order. So we are having select name from instructor, where department name equal to physics, and a new clause we are making use of, order by name. So the list of the instructors will be ordered in alphabetical manner, in ascending order. So by default we are having ascending order, right? One more example, if we want to order the data in descending order, then we need to make use of this keyword descending, right? So by default we are having ascending order, right? If we want to order the data in descending order, then we need to make use of this keyword DESC, right? It is possible for us to make use of more than one attributes for ordering. It is possible that we may order the data in ascending order for one attribute and in descending order for another attribute. So let's see an example how we can make use of multiple attributes for ordering. So list the entire instructor relation in descending order of salary. List the entire instructor relation in descending order of salary. If several instructors have the same salary, we want to order them in ascending order by name. At a time, we need to make use of different attributes for ordering. We want to order all the instructors according to the descending order of salary. And if two instructors are having same salary, then we want to order these instructors according to the name in ascending order. So the statement we are writing is select star from instructor, order by salary descending, comma, name ascending. So first it will look for salary in descending order, and if two salaries are same, then it will order the records as per the instructor's name in ascending order. So let's try to practically see the results of these statements and then we'll conclude, right? So now let us try to write this statement. The first statement, name from instructor where department name equal to physics, order by name. Here I am not writing anything ascending or descending. By default it is ascending. So select name from instructor where department name equal to physics, order by name. So we are listing out all the instructors from physics department and will be having the alphabetical list of names. So E and then G, right? So it is ordered according to name. If I include A, S, C, then also I'll be getting the same order, ascending order, right? So by default it is ascending. If I want to have the descending order, then I'll be using DESC. So I'll get the data in descending order, correct? Now let us see how we can use multiple attributes with different sorting orders. So select star from instructor, order by salary. We want to order according to descending order of salary. So DESC, comma, if two salaries are same, then we want to order according to name in ascending order. So select star from instructor, order by salary in descending order, and then name in ascending order. right? So if we execute this, just look at the result. See, we are first ordering according to the descending order of the salary. So first is 95, second is 92 and so on. So if we are having two salaries, those are same. Is it? Is there? Yes. See here, we are having two salaries which are same, 80,000, 80,000. So in this case, what has happened? We have ordered the data according to name in ascending order. So Kim 80,000 comes first and then Singh 80,000. Got it? Yes? Got it?
Yes, ma'am.
Is there any doubt so far?
No, ma'am.
Fine. So let's conclude today's session. I hope you must have understood all the constructs, those we have studied today. So we have used initially, the construct of SQL wherein we are using more than one tables. So we have seen the Cartesian product. Then we have seen why there is a need to impose the condition whenever we are having the Cartesian product, because we want to match the common attributes, right? Then we have seen how to rename the attributes as well as how to rename the relations. We have seen the concept of tuple variables. Then we have seen few string operations and two new constructs, like and not like, to match the substrings or not to match the substrings. Okay. Similarly, we have seen a new construct, and that is order by, to sort the data in our tables. So this is simply the visual effect. So by order by clause, it is possible for us to display as per the specific order. Also, we have seen how we can order the data based on multiple attributes also. Right? So with this, I think you must have understood all those concepts. So let's stop today. We are having the quiz and I have posted the quiz link in the Google Classroom. So attempt the quiz based on SQL, right? And the link will be open by 1 o'clock. So before that you are supposed to submit the quiz. Fine. So thank you.